We all know 3D printing. You design something, print it, and there it is, locked in that shape forever. You print a cup, it's always a cup. But what if there's a new kind of printing that adds a whole new dimension, time? Welcome to 4D printing, where objects change shape on their own, over time. It's called programmable matter. Imagine printing a flat sheet, dunking it in water, and it folds itself into a box. Or a pipe that expands to seal a leak, or sneakers that tighten when you run. No motors, no wires. The material itself is the machine. MIT's self-assembly lab is leading the way, showing what's possible when materials get a mind of their own. So, how does it work? The secret is smart materials. Hydrogels swell in water. Shape memory alloys like nitinol snap back into shape when heated. Shape memory polymers respond to light or temperature. With a multi-material 3D printer, you can layer different materials, like rigid plastic and hydrogel. Add water, and the hydrogel swells, bending the whole thing into a new shape. By planning the pattern, you can print origami that folds itself. Skylar Tibbetts at MIT is a rock star in this field. Let's talk furniture. Shipping is expensive, especially when half the box is air. IKEA ships flat packs, so you have to build it. Good luck finding that Allen key. With 4D printing, you could get a flat board, spray it with water, and it folds itself into a chair. That's self-assembly. The same idea could work in space. Send up a flat satellite and let it unfold into a solar sail. Now, plumbing. Pipes burst when they freeze. Major headache. Imagine a 4D printed pipe that senses the chill and expands so it doesn't crack. Or a pipe that self-heals by swelling to seal leaks as soon as water escapes. Even smarter, a valve that closes if the water's too hot, all without electronics. The medical world's in on this, too. Stents, tiny tubes that keep arteries open, have to be small to insert, but big enough to work. With 4D printing, you can make a stent that's tiny at first, then uses body heat to expand and lock in place. And for babies with collapsed airways, custom trachea splints are printed to grow with the child, then dissolve when no longer needed. What about clothing? MIT's Tangible Media Group made workout gear with vents that curl open when you sweat and close when you dry off. That's thanks to bacteria in the fabric, reacting to moisture. Imagine a jacket that's waterproof in the rain, but breathes in the sun. Robots benefit too. 4D printed soft robots move without motors, like a gripper that closes around a fish, powered just by water. Great for deep-sea research or picking fruit, with the environment doing the work. Could we 4D print buildings? Maybe one day. Imagine programmable cement, or walls that breathe, or roofs that tilt to follow the sun. For now, self-repairing concrete, using bacteria to fill cracks, is our first step. But there are limits. Hydrogels can be slow. It might take minutes or hours to move. The materials aren't super strong yet. Some only fold once. And two-way reversible movement. That's still expensive and tricky. But in the future, hardware becomes software. We'll design how things behave right into the atoms themselves. The line between material and robot will blur. So here's my question. Would you trust a chair that built itself? Let me know below, and don't forget to shapeshift that subscribe button.